Hi, this video is about how to find extra roots of a cubic or a quartic given one root. I'm going to start off by explaining the basic idea with a quadratic equation. Here's a quadratic equation, x squared plus px plus q equals 0. Suppose you found the roots a and b. That means you can factorize that quadratic into x minus a, x minus b. And in other words, x minus a times x minus b is exactly the same expression as x squared plus px plus q. And if we multiply out that left-hand side, that tells us that a plus b, which is the sum of the roots, is equal to minus p. It's equal to minus the coefficient of the second highest power on the right-hand side. AB, which is the product of the roots, is equal to the constant term on the right-hand side, which is equal to Q. Now, these rules apply pretty much to cubics and to quartics too. So, with a cubic or a quartic, you will have three roots, obviously, or four roots. But still, the sum of the roots will be equal to the minus the coefficient of the second highest power. It's always a minus for the sum of the roots. The product of the roots, there's a slight twist here. The product of the roots is equal to minus the constant term for a cubic. And it's equal to plus the constant term again, like it is for a quadratic, for a quartic. The reason why is that with a cubic, when you factorize it, you would have something like that. When you multiply that out, it's minus a times minus b times minus c. You have three minuses, which produce a minus. Whereas with a quadratic, you have two minuses, which produce a plus. With a quartic, you have four minuses, which also produce a plus. So, let's take a cubic equation. Here it is, 2z to the cubed minus 10 z squared plus 16z minus 12 equals 0. First note of caution, to use these rules about the sum of roots and the product of the roots, we first have to make the coefficient of z cubed 1. Obviously there has to be some rule about the coefficient of z cubed, or we could just multiply the whole equation through. You wouldn't change by 2 or 5 or 57. You wouldn't change the roots at all, but you could change the sum of the roots, which doesn't make sense. So the rule is the coefficient of the highest power of z cubed in a cubic has to be 1. You notice I'm using z. We normally use that for equations where we think the roots are going to be complex numbers. So let's change this to that. All we've done is divide both sides through by 2. We haven't changed the roots. Right, perhaps we're given that one of the roots is z equals 3. We want to find the other two roots, so let's call the other roots a plus or minus bi. You know, if a complex number is a root, its conjugate is a root. So if a plus bi is a root, a minus bi is a root. And we're going to do a calculation which will find a and b. Just one note to save you worry. if you end up doing this calculation, you end up finding that b is not a real, but an imaginary number, that means that a plus or minus bi will give you two real numbers, and that's all right. Most of the examples you're likely to get in the tests, in the exams, will have two complex roots here, but if b comes out imaginary, that just means you've got real roots. That's all right. Sum of the roots minus the coefficient of the second highest power, which is 5. Remember, if we didn't have a z squared term here, if it was just z cubed plus 8z minus 6, we wouldn't say, aha, the sum of the roots must be minus 8. We would say the coefficient of z squared is 0, even if it's not written there, and the sum of the roots would be 0. Here, you can see the z squared term, and the sum of the roots is 5. If you couldn't see the z squared term, the sum of the roots would be 0. So 5 is equal to 3 plus a plus bi plus a minus bi. Bi terms cancel, so a is equal to 1. To find b, we have to use the product of the roots. The product of the roots here is plus 6 or minus 6. It's plus 6 because with the cubic, the product of the roots is minus the constant term. So 6 is equal to 3 times a plus bi times a minus bi. We already know what a is, so we can rub out a and replace it by 1. And we know how to multiply that out. That's just equal to 3 times 1 plus b squared. So divide through by 3. 1 plus b squared is equal to 2. Therefore, b squared is 1, and b is plus or minus 1. So the other roots are 1 plus or minus I. That's done. We could check by just plugging those values for z, 1 plus or minus I, back into the original equation. You can pause here, and I'm going to go on to the second example. Second example, so this is an easier one. Suppose I had exactly the same equation, but I'm told to start off with that 1 plus I is a root. Then I know straight away a second root. That's a root. You have any complex root, its conjugate is also a root. So I've only got the third root to find. Call the third root a. And now I will only need to do the sum of the roots. I don't even need to look at the product of the roots. The sum of the roots is 5 as before, and that's equal to, that is equal to 1 plus I plus 1 minus I plus a. The i's cancel out, therefore a equals 3, which is what we expected to get. Right, pause a minute. I'm going to do the third example, which is a quartic. Z to the fourth minus 4z cubed plus 11z squared minus 14z plus 10 equals 0. And what we know is that 1 plus I is a root, and we want to find the other three roots. Step number 1. 1 minus I is also a root. Any complex number which is a root, its conjugate is also a root. Call the other two roots A plus or minus BI. Now we do the same sort of thing. Sum of the roots minus the coefficient of the second highest power. Minus a minus 4 is 4. Remember, if we didn't see a z cubed term there, the sum of the roots would be 0. Remember also that we'd had to check first to see that the coefficient of z to the fourth was 1. If it wasn't, we would divide through by everything to make that equal to 1 before we use these rules. Sum of the roots is 4, and that's 1 plus I plus 1 minus I plus A plus BI plus A minus BI. Looks complicated, but a lot of it cancels out. So you've got 2A plus 2 equals 4, so A equals 1. To find B, we use the product of the roots. The product of the roots is plus the constant term, because it's a quartic, plus, not minus, as it would be for the cubic, so it's plus 10. So, what we got is that 1 plus I times 1 minus I times A plus BI, and we know A is 1, so that's 1 plus BI times 1 minus BI is equal to 10. 1 plus I times 1 minus I is just 2. 1 plus BI times 1 minus BI is just 1 plus B squared. So twice 1 plus B squared is equal to 10. So 1 plus B squared is equal to 5. So B squared is equal to 4. So B is equal to plus or minus 2. So the other two roots are 1 plus or minus 2i. And that completes the solution of all the roots of that quartic.